In the previous video, I had covered pre-milling and milling as the first section of sugarcane processing. We found out that in this section, sugarcane is prepared by reducing it to shredded cane. Juice is extracted from this shredded cane. In this video, I'm going to cover juice treatment as the second section of sugarcane processing. Extracted juice is a turbid, grayish-green liquid with insoluble and soluble impurities. It's acidic in nature with pH of around 4.5 to 5.5. Examples of these impurities are we have air, soil particles, fibrous materials, coloring matters like anthocyanins and chlorophyll, proteins, amino acids, fructose, glucose, pectin, starch, waxes, gums, sometimes dextran, and finally minerals. The main objective of juice treatment section is to remove all the impurities that can hinder or slow down sugar crystallization. Also, in this section, the pH of juice is raised to neutral level. Operators at this section should be very careful when handling juice to minimize sucrose, fructose, and glucose loss. You may ask yourself, why should they maintain the fructose and glucose in the juice, yet we are concerned with sucrose alone? This because fructose and glucose are highly soluble in water as compared to sucrose. Hence, their presence in the juice will make sucrose to crystallize at a faster rate. This section is divided into three subsections. That's liming, where lime is added to juice; clarification, where mud is separated from clear juice; then filtration, where the remaining juice in the mud is removed. When juice reaches this section, it's first heated in dynamic and primary heaters to raise its temperature to around 75 degrees Celsius. This enhances the solubility of lime in juice. Juice from these heaters is pumped to liming tank. Remember, lime is slightly soluble in cold water but soluble in hot water. Therefore, milk of lime is prepared by mixing hot water with lime powder. The chemical composition of milk of lime is calcium hydroxide. Milk of lime is mixed with juice, the liming tank. Recommended phosphate content range is between 300 to 500 ppm. In case a sample of extracted juice is analyzed in the lab and found out that the phosphate content is below 300 ppm, phosphoric acid is added to juice as it enters the liming tank. It's important to maintain optimum level of phosphate content in the juice because this leads to, number one, great colloidal removal since precipitates absorb and hold colloids present in the juice. Number two, it leads to better flocculation and clarification. Number three, less calcium oxide will be found in clear juice. Calcium hydroxide neutralizes the free acids and added phosphoric acid to form salts and water, hence raise the pH of juice from 5 to around 8.4. Examples of these salt forms are calcium phosphate and calcium citrate. Remember, calcium phosphate is an insoluble salt, hence precipitates. These precipitates absorb and hold the impurities present in the juice. The pH of lime juice has to be maintained between 8 8.0 to 8.4. This because pH below 8 shows that there's little lime added to juice, and if little lime is added to juice, there will be poor settling since less precipitates will be formed. Excess lime leads to precipitation of calcium oxide under high temperature. Hence, this calcium oxide settle at the bottom of evaporators, forming scales. So for the operator to maintain this pH, he has to observe the following. Number 1, the pH of lime juice has to be checked hourly so that in case there's a deviation, the operator applies the corrective measures. Number 2, milk of lime prepared should have Brix of 10. Number 3, lime powder used to make milk of lime should have calcium oxide content of around 65%. Number 4, the operator should be keen on milling rate and juice flow fluctuations. Finally, the reaction time between juice and lime should be around 15 minutes. This juice from lime juice tank is pumped to secondary and tertiary heaters to raise its temperature to around 105 degrees Celsius. The aim of this heating is, number 1, to kill microorganisms that can cause sugar loss, as discussed in the previous video. Number 2 is to destroy invertase enzymes. Number 3 is to denature proteins. Remember, proteins work as a stabilizer and it can prevent the precipitate from settling down in the clarifier. Number 4 is to make air to be light for easy separation from juice. Juice from tertiary heaters is pumped to flash tank. The function of flash tank is to remove air and vapor from juice. Air and vapor is removed from juice because the presence of this prevents proper settling of solid particles. The flash tank also reduces the flow rate of juice, hence enhance settling of solid particles. Juice from flash tank is then pumped to clarifier. Settling time for juice in the clarifier has to be minimum to prevent charring of juice. Therefore, flocculants are added to juice as it enters the clarifier to enhance or increase the rate of flocculation and sedimentation. Flocculants are polyelectrolytes that have active sites where the small precipitates formed attach to form bigger and heavier precipitates which can settle at a faster rate. The clarifier has 5 chambers and each chamber has 4 corks. It also has a stirrer which collects mud together. The function of the clarifier is to separate suspended solids from the juice. This is done by allowing the solid particles to settle at the bottom, leaving clear juice at the top. This clear juice is pumped out through cork 4 to clear juice tank. Then from clear juice tank it's pumped to evaporators. Clear juice should be yellowish in color, free from suspended solids, and should have a pH of around 7 to 7.4. The presence of suspended solids in clear juice can affect the remaining stages of sugarcane processing in the following ways. Number 1, they form scales in the evaporators and heaters, hence reduce or decrease heat transfer. Number 2, Increase syrup viscosity, causing a difficulty in boiling. Number 3, hinder crystallization of sugar crystals, hence leading to sugar loss and production of molasses with high purity. Finally, high viscous massacute reduce cooling rate at the crystallizer. The pH of clear juice should be maintained at neutral level because if this clear juice has pH below 7, hydrolysis of sucrose will be accelerated since this clear juice is subjected to high temperature. Also, alkaline condition and high temperature will enhance caramelization. Caramelization is the decomposition of glucose and fructose, producing coloring pigments. These coloring pigments can affect the final color of sugar. Precipitate that settle at the bottom of each chamber of the clarifier is referred to as mud. This mud still have sugar, hence the juice in this mud has to be filtered, has to be removed from this mud. The mud level of each chamber has to be checked hourly to make sure that mud does not reach Cork 4. Remember, we need clear juice that does not have suspended solids. Mud from each chamber is drained out through Cork 1 to mud overflow tank. This mud is then pumped to mud mixer where it's mixed by Bagasilo. Bagasilo is just fine screen bagasse. The function of Bagasilo is to make mud porous for easy filtration. Mud from mud mixer is pumped to the trough. The trough is under rotary vacuum filter. Trough apply mud on rotary vacuum filter as it rotates. The function of rotary vacuum filter is to remove all the juice or to suck all the juice present in the mud under vacuum pressure. Hot water is sprayed on the mud applied on rotary vacuum filter for maximum removal of sugar from mud. The filtered juice is pumped to liming tank for pretreatment, while the hard residue that remains on the vacuum filter is referred to filter cake. Filter cake is scraped off from the rotary vacuum filter, dropped to conveyor belt. Conveyor belt carry this filter cake to the collecting tractor. Filter cake is used in the field as manure. Remember, we have white sugar and brown sugar. So in case the factory want to produce white sugar, sulfur 4 oxide is sucked through juice by vacuum. This gas acts as a bleaching agent which removes all the coloring matters in the juice, producing shining and transparent liquor. I'm done with juice treatment. In the next video, I'll cover evaporation as the third section of sugarcane processing. Thank you very much for watching my video. I highly welcome all the new subscribers. If you are watching my video for the first time, kindly subscribe to my YouTube channel so that you can get more videos that cover properties of food products and the processes involved in making those products. See you in the next video.